So in this problem, we want to find the slope of the line that passes through the two given points. When we do a problem like this, we label the points. It does not matter which one I call x1, y1, and which point I call x2, y2. The thing to remember, though, is that when you are finding your slope, whichever y-coordinate is first in the subtraction in the numerator, the corresponding x-coordinate has to be first in the subtraction in the denominator. So, and remember that the rise, which is the difference in y values, must come first or in the numerator, and x's, the change in x, the difference between the x-coordinates of the 2 points, is the run, and that goes in the denominator. So each y needs to be over its corresponding x. So this is my formula for slope, and it gives me the rise over the run. Rise is the change in y. Run is the change in x. And so, remember, it doesn't matter which point I refer to as x2, y2. We've called the negative 3, negative 4, x2, y2. And we have called negative 5, negative 3, x1, y1. All right, so you just want to check that your y's are in the numerator and your x's are in the denominator. Y's in the numerator, x's in the denominator. So negative 4 minus negative 3 is the same as negative 4 plus positive 3. Negative 3 minus negative 5 is the same as negative 3 plus positive 5. So we have negative 4 plus 3, which is negative 1, over negative 3 plus 5, which is 2. So our slope is negative 1/2. So I would be selecting A and entering that as my answer. Of course, the box would allow your answer to fit in if you were actually doing this online. Okay, so this is how you would work exercise 1 in section 2.5. Now let's look at exercise 3 from section 2.5. I want to find the slope of the line containing the given points. And I want to point out that I don't know what the confusion is here with how this printed out, but this point is the point 3, 0. And so to find the slope, I do what we just did. One of my points is x2, y2. So I'm going to say y2 is 0, x2 is 3, y1 is negative 4, x1 is negative 2. So I am actually subtracting from 0 a negative 4 and I'm subtracting from 3 a negative 2. So 0 minus negative 4 is 4. 3 minus negative 2 is 5. So my slope is 4/5. And you can see that this line is rising from left to right. As I move from left to right, if I'm at a point on the line and I move from the line to the right, then I have to go up to get back on that line. So that's a line with a rising slope, which essentially is a positive slope. All right, so I would shade A, and I would enter 4/5 as my answer. And you would be typing that in. All right, here we want to find the slope and y-intercept of the equation. So the equation is given to us as negative 5x plus y equals negative 6. So I need to isolate y and make sure everything on the other side is simplified. So I'm going to isolate y by adding a negative 5x to both sides of the equation. So y is 5x minus 6. So when y is isolated on one side of the equation, everything on the other side is simplified. The coefficient of x, which in this case is 5, is my slope. And the constant on the side of the equation opposite the isolated y is my y-intercepts y-coordinate. A lot of time we'll just refer to it as the y-intercept, and we refer to that as b, and in this case that's negative 6. Remember, y equals the slope times x plus b. So one thing to note is that the slope is merely a number that measures how the line is changing. Here we're asked to find the slope and y-intercept of the line whose equation is given. So we want to solve for y. So we want y isolated so that we can determine the slope and y-intercept. So I'm going to subtract 5x from both sides of the equation. I can also look at it as adding a negative 5x. Okay, all right. So we now have 9y equals negative 5x plus 18. And we are going to divide every term by 9 in order to isolate y on the left side of our equation. So y equals negative 5/9 x plus 2. So in this particular case, our slope is negative 5/9. Once y is isolated on one side of the equation, then the coefficient of x is our slope. The y-coordinate of our y-intercept, sometimes we just simply say our y-intercept is 2.